Now I am going to discuss about the atomic structure. So what is atomic structure? So this is the very basic chapter of the chemistry. Okay, this is one of the important lesson for the JEE mains and NEET. Compulsory one question they are going to ask in the JEE mains or NEET level. One or two questions they are going to ask. Okay, so now let us start our chapter, that is atomic structure. Okay, what is atomic structure? Before that we should learn about what is chemistry. Okay, what is chemistry? What is chemistry? Okay, chemistry is a branch of science. Chemistry is a branch. Chemistry is a branch of science which deals deals with the properties properties of matter. The properties of matter. Okay, so it deals with the properties of matter. Chemistry is a branch of science. We know what is a science. Science is a knowledge, knowing about ourselves, our surroundings, that all known as what? Science. And chemistry is a part of science. Okay, and it deals with the properties of matter. Properties in the sense of physical and chemical properties. Okay, now let us see matter. What is matter? What is matter? Okay, so matter means anything anything that occupy that occupy anything that occupy space and has some mass. Anything that occupies space and has some mass, that is called what? Matter. Okay, so here say for example pencil is a matter, chalk piece is a matter, because why? They have space and they occupy, sorry, they have some mass and they occupy some space. Say for example pen, pencil, etc. Pen, pencil, water, water, air, etc. So all this we can consider as matter. Okay, so why? Because they occupy some space and they have some mass. We ourselves also a matter. Okay, now let us see classification of matter. So classification of matter, how we can classify the matter. Okay, so matter can be classified into two types. Matter can be classified into two types. So that is, first one is physical classification. Physical physical classification and chemical classification. Physical and chemical classification. Chemical classification. So in physical classification we are having, in physical classification we are having solids, solid, liquid, gas, solid, liquid, gas, and in physical classification mainly we are having three different states. They are they are the solids, liquids, and gases. Solids, liquids, and gases. So these are the main three physical states of matter. Based on the particle arrangement, we can say some of the matter is solid, some of the matter is liquid, some of the matter is gases. Okay, so for example, this pen is a solid. Water what we drink, that is a liquid. Air what we inhale, that is called gas. Okay, next, apart from this we are having two more physical states. They are plasma and Bose-Einstein condensed state, BEC, Bose-Einstein condensed state. Okay, so next, coming to chemical classification. So in chemical classification we can classify the matter into we can classify the matter into two types, that is pure matter and impure matter. Pure matter, pure and impure, pure and impure matter. Okay, so pure matter again classified into two types. It is again classified into two types, that is the first one is elements, elements and compounds, elements and compounds. Okay, so here again elements are classified into different types, four types they are classified. They are classified into four types again. There the first one is metal, metal, non-metal, metal, non-metal. Okay, non-metal and metalloid, 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 noble gas, noble gas. Okay, metalloid and noble gas, noble gases. Next, impure compounds. Again, impure matter is again classified into two types. That is that is homo. That is okay. So impure matter. we'll see impure matter. Impure matter again classified into two types, that is homo and hetero. Homo and hetero. Homo and hetero. Okay. Homogeneous mixtures and heterogeneous mixture. Homogeneous mixture, heterogeneous mixture. This is about classification of matter. Okay, so how we are going to classify the matter? So first of all, what is matter? Matter is anything that occupies space and has some mass, that is called matter. Example, take pencil, pen, water, air. Okay, so classification of matter. When you come to the classification of matter, matter classified into physical classification and chemical classification. Physical classification means it is based on the physical properties. The classification is based on the physical properties, that is called physical classification. If the classification based on the chemical properties, that is called chemical classification. So in physical classification we are having mainly three types: solids, liquids, gases. Based on the particle arrangement, everything and their properties, we classify the matter: solids, liquids and gases. Again we will discuss about them in detail in states of matter. Okay, plasma, it is very high energetic state of matter where matter exists as ions and electrons. Next, BEC, Bose-Einstein condensed state. Okay, so it is artificially prepared. So here this state we can prepare by cooling the matter at lower temperatures. Okay, next, chemical classification. So when you come to the chemical classification, based on the composition properties, that properties, based on the properties we can classify the matter, that is called chemical classification. So chemically matter is classified into two types. The first one is pure matter. So here what is a pure matter? Pure matter means contain only one substance. Contain only one substance. Contain only one substance. Pure matter contains only one substance. Contain only one substance. Only one substance. That is called pure matter. So pure matter again classified into elements and compounds. Okay, so your elements are again classified into metals, non-metals, metalloids and noble gases. Next, come to the impure matter. Impure matter means contain more than one substance. Impure matter contain more than one substance. Contain more than one substance. Contain more than one substance. That is called impure matter. Okay, now let us see about early ideas about the matter. Early ideas about the matter. Okay, what are the early ideas? Early ideas about matter. Okay, so what are the early ideas about the matter? So first of all, Greek philosophers. Greek philosophers. Greek philosophers. So Greek philosophers, Greek philosophers like Democritus and Leucippus. Democritus and Leucippus. So what they did, they divided the matter continuously. They took some matter and they divided it continuously. Okay. See, you'll see here. So they took some matter and they divided it continuously with the help of sharp knives. Say for example, let us consider it as the matter. So they divided the matter continuously. Why they divided the matter continuously means to know what matter actually contains. Okay, why they divided the matter continuously? Because to know what matter actually contains. Okay, so for that purpose they divided the matter continuously. So how they divide this matter continuously? By using the help of sharp knives. So they used very sharp knives. Okay, so why they used only sharp knives means in that age nearly 400 BC, in that age there is no more development in the science and technology. Okay, sharp knives which are made by using rocks and also horns of the animals. Okay, so by using them they divided the matter continuously. So when they divided the matter continuously they got very tiny particles. They got very tiny particles. Tiny particles. Tiny particles. These are further not dividable. Means we cannot divide further them. We cannot further divide them. So for these tiny particles they gave one name, atom. Okay, so the word atom is derived from the atomio. It is derived from atomio. Derived from atomio. Atomio. What is the meaning of atomio? What is the meaning of atomio? That is uncuttable. Uncuttable or undividable. Uncuttable or undividable, which means children, so we cannot divide. We cannot divide these tiny particles according to Greek philosophers. Okay, next so now finally what is the meaning of atom? According to them, the tiny particle of the matter. The tiny particles. Tiny means very small. The tiny particle of the matter. Tiny particle of the matter is called atom. So what is atom? The tiny particle of the matter is called atom. Okay, next Indian philosophers. Indian philosopher. Indian philosopher. Okay, so here Indian philosopher like Maharshi Kanada. Kanada. Maharshi Kanada also did the same experiments, which means he also divided the matter continuously with the help of sharp knives only. Because with him also there is no sophisticated devices are available. That's why what he did, he also divided the matter continuously with the help of sharp knives. So when he divided this matter continuously with the help of sharp knives, what he observed? What he observed? Formation of very tiny particles, means he got very tiny particles. So for these tiny particles, for this tiny particles, for these tiny particles, he gave one name, that is Anu. So these tiny particles, he gave one name Anu. So derived from the Sanskrit word, it is Sanskrit word. So what is the meaning of Anu? What is the meaning of Anu means ultimate particle. Okay, so what is the meaning of Anu? Ultimate, ultimate, ultimate particle, ultimate particle, and which we cannot divide. We cannot divide, which we cannot divide further, which means again we cannot divide. It is impossible to divide the these tiny particles. Okay, these are the early ideas about the matter. Okay, next let us see John Dalton's atomic theory. Dalton's atomic theory. Okay, so John Dalton's atomic theory, and so parallelly I am going to discuss about the modern atomic theory. Okay, so Dalton atomic theory, Dalton atomic theory, and simultaneously we see modern atomic theory also. Okay, first let us see the John Dalton's atomic theory, which is proposed in 1803. Okay, which is proposed in 1803. And what is the John Dalton theory means, children? Okay, so here he told something about the atom. He given some important properties, some important relations about the atoms. Okay, so according to John Dalton's atomic theory, atoms can neither created nor destroyed. Atoms neither created nor destroyed, nor destroyed in a chemical reaction. Okay, atoms neither created nor destroyed in a chemical reaction means it tells about the conservation of atoms. Means newly we cannot create any other atoms, and we cannot destroy the existing atoms, but what we can do, we can convert that atoms from one compound to another compound. That is the meaning. And atoms are the tiny particles of the matter. The second point is atoms are tiny particles of the matter. We cannot divide the atom further. Atoms are tiny particles. Tiny particles. Atoms are tiny particles of matter. We cannot divide. We cannot divide them further. We cannot divide them further. Okay, next means atoms we cannot divide further means they are only very very tiny particles. Means which are atoms are the building blocks of the matter. Okay, next atoms of same element are alike. Atoms of same element, atoms of same element atoms of same element are alike. Atoms of same element are alike. Atoms of same element are alike means, children, if you compare the atoms of hydrogen, see for example, here I am going to take the atoms of hydrogen. So when you take the atoms of hydrogen, for example, you just consider these are the three hydrogen atoms. Okay, so these are the three hydrogen atoms. You just consider like this. Okay, so just consider we are going to take the three hydrogen atoms. Among these three hydrogen atoms, there is no difference. All these are same. All these are same. Means there is no different. So there is no different between these hydrogen atoms. Means all properties are same, including their physical properties, chemical properties, mass, atomic number, number of protons, number of electrons, everything is same. Next, when you come to atoms of different elements, atoms of different elements, atoms of different elements, atoms of different elements are completely different, are completely different. Atoms of different elements are completely different. Say for example, here we are going to take hydrogen and helium, and we are going to compare. Okay, take hydrogen and helium, and we are going to compare hydrogen and helium. So one, at least single property is also not same. Completely they are having entirely different properties. Next, atoms combine in small hole ratio. Atoms combine in small hole ratio. Atoms combine so atoms combine in small hole ratio, small hole ratio to form compounds, okay, atoms combine in small hole ratio to form compounds. So for example, water, H2O, water. Okay, so it's not support. So we take H2O, okay, and CO2. Okay, so here H2O, CO2 contain how many atoms? Two atoms of hydrogen and one atom of oxygen. Carbon and oxygen means one atom of carbon and two atoms of oxygen. One atom of hydrogen, two atoms of hydrogen and one atom of oxygen. Likewise, only in small hole ratio only they are going to combine and to give compounds. Next, atoms only involved in chemical reaction. Okay, next what is saying about atoms only involve atoms only involve in chemical reaction, in chemical reaction. Okay, in chemical reaction. So this is about the John Dalton's atomic theory. Okay, so once again revise, what is the John Dalton's atomic theory? Atoms neither created nor destroyed in chemical reaction, means conservation of atoms is telling. Okay, means next atoms are tiny particles of the matter, we cannot divide them further, means it is impossible to divide the atom, means they are fundamental particles of the matter. Next, atoms of some elements, same elements, sorry here, same elements, atoms of same elements, atoms of atoms of same element. Okay, atoms of same element, atoms of same element, atoms of same element are alike. For example, we are going to take hydrogen, hydrogen. So when you compare the properties of these three hydrogens, they are having same mass number, same atomic number, same number of protons, same number of electrons, and same chemical properties. Next, atoms of different elements. Atoms of different elements are completely different. For example, we are going to compare the atoms of hydrogen, atoms of helium. They are having completely different properties, like different atomic number, different mass number, different physical properties, different chemical properties. Okay. Next, atoms combine in small hole ratio only to form compounds, means 2 or 3 atoms, 4 or 4 5 atoms, maximally 5 6 atoms, they are going to combine and they give compound. And the next, atoms only involved in the chemical reaction. Okay, next, this is about the John Dalton's atomic theory. Next we will see about the modern atomic theory. Modern. Okay, we'll change the color. Modern atomic theory. Modern atomic theory. Modern atomic theory. So after discovering subatomic particles like electron, proton, neutron, and some of the properties of the atoms, this theory was proposed. So first, according to modern atomic theory, atoms can be divided. Atoms can be divided further. Okay, atoms can be divided further. Okay, next, means when you divide the atom, when we divide the atom, we get electrons, protons, neutrons. We get electron, proton, neutron, mesons, and pions, and pions, okay, etc. We'll get these type of fundamental particles, means atom is no longer indivisible, atoms can be divided further. Atoms no longer undividable, atoms can be divided further. Okay, which means so here we are coming, so let us consider this is the atom. According to John Dalton's atomic theory, atoms cannot be divided further, but according to modern theory, atoms we can divide the atoms. We can divide the atoms. When you divide the atom, what you get? Electron, proton, neutron, pions, mesons, neutrino, anti-neutrino, anti-proton, etc. So many subatomic particles we will get. Among them, electron, proton, and neutron are the main subatomic particles. Okay. Next, next. So here John Dalton is saying atoms of same element are alike, but atoms of same element are like only. Atoms of same element. Atoms of same element are like. Atoms of same element are like. So what is the meaning of this? What is the meaning of this? So here when you take some, okay, when you take the hydrogen, when you take the hydrogen only, so here we are having H11, H12, H13. Means what all these are? Isotopes. Isotopes. Okay. What is the meaning of isotope, children? Isotope means the atoms of same element are have different mass number. Atoms of same element have different mass number. Atoms of same element. Atoms of same element have different mass number. Different mass number. So that is called isotope. Again we will discuss about the isotopes. Even though we are having the same element, atoms of same element, they are having some mass number is different. Okay, again we will discuss in detail about the this isotopes. Next, atoms of different elements. Atoms of different elements. Atoms of different elements are not completely different. Okay, atoms of different elements are not completely different. See, for example, here we can take okay. So for example, here we can take okay, not this one. You take the different elements. Atoms of different elements are not completely different. For example, you take argon and calcium, argon and calcium. You take argon, atomic number 18, mass number 40. Calcium, atomic number 20, mass number 40. Okay, so here even though they are atoms of different elements, they have the same mass number. Means atoms of different elements may are not completely different. So these are called isobars. iso Isobars. These are called isobars. Okay, next you take one more example, like sodium Na, mass atomic number 11, mass number 23. Magnesium 12, 24. So they are having same A minus Z value. A minus Z here, how much we will get A minus Z? So here 23 minus 11, you will get 12, and here also 24 minus 12, that is equal to 12. Means they have same number of neutrons. They are called isotones. Isotones, which means atoms of different elements are not completely different. They have some similarities. Next, let's see next points in the modern atomic theory. So atoms of, so in the last we have discussed about atoms of same element are alike. Means atoms of same element are like, means some properties are different are there. Atoms of different elements are not completely different, means some properties similarity is there. Next we'll see atoms combine in large hole ratio also. Atoms combine in large hole ratio, also. Atoms combine in large hole ratio also. Okay, so for example we'll see glucose is there. Formula C6H12O6. What is the formula of glucose? C6H12O6. So in C6H12O6, here 6 plus 12 plus 6, total 24 atoms are combined. And when you take the proteins, biomolecules like DNA, RNA, etc., there are more than 100 atoms are also present. For example, fullerene you take C60, 60 atoms are there. So likewise, so your atoms not only combine in small hole ratio, and they can combine in the large hole ratio also. Next, atoms only involved in the chemical reaction. Atoms only involved in the chemical reaction. Atoms only involved in the chemical reaction. Okay, so this is about the John Dalton theory and modern atomic theory. So here, except this last point and the first point, remaining all contradictions only in the John Dalton's atomic theory. Once let us see here. So atoms neither created nor destroyed in a chemical reaction. This is true according to John Dalton theory, and modern theory also says that atoms cannot be created and destroyed. Means John Dalton theory explains the law of conservation of mass, law of combinations very successfully. Next, atoms are tiny particles of matter. We cannot divide them further. But this is the false. Why this is false? Atoms can be divided. When you divide the atom, you get electron, proton, and neutron, and pions, mesons, neutrino, antineutrino, etc. Okay, so modern theory says that atoms can be further divided. Okay, according to John Dalton theory, come here, atoms of same element are alike. So atoms of same element are alike means, so when you see the atoms of one element, they are completely same, there is no single property also different. But modern theory says atoms of same element are like only means, there are some properties different is there. What are the different properties? Here we are having isotopes, even though they are atoms of same element, their mass number is different. Next, atoms of according to John Dalton theory, so this is also you can strike up, atoms of different elements are completely different. So when you compare a hydrogen and helium, they are having completely different properties. But when you see according to modern theory, atoms of different elements are not completely different, not completely different. Why? Because we are having isobars, isotones, and isodiaphers also there, isotones and isodiaphers, we will discuss them later. Okay. Next means, this point also we can strike out, atoms can combine in small hole ratio to form compounds, like water only for 2 plus 1, 2 plus 1 3 atoms, and here 1 plus 2 3 atoms, like that. So only in small hole ratio only they are going to combine and they will give compounds. But according to modern theory, atoms can combine in large hole ratio, like glucose, proteins, biomolecules, fullerene, etc. So means this point is also false according to John Dalton theory. Means atoms combine in small hole ratio, they are telling. This is also false. Next, atoms only involved in chemical reaction. According to modern theory also, atoms only involved in the chemical reaction. So this is correct. Okay, this is about the comparison between the modern theory and John Dalton's atomic theory. Okay. In the next video, I will discuss discovery of subatomic particles. Okay. Thank you.